So this is lesson 5. This is all about special triangles, exact values, and the unit circle. Most of this lesson we covered when we were on our first day, when we made our unit circle and we're investigating radians and things like that. So we're actually going to skip to page 5. And we're going to see that here's a completed version of our unit circle. It should be basically the same as what you have on your poster. And here it just gives us some extra information. So the circle above with a radius of 1 unit is called the unit circle. So it's called the unit circle because the radius is 1. It is important to understand how it works. So remember this formulas for sine are y over r. So why do we say it is y over r? Well, remember we always have our reference angle on the x-axis. The opposite side is then this, sorry, that should not be a, the opposite side here is then our y value because it's the vertical one. And the radius, because this is on a circle, the radius is the same as the hypotenuse. So that's why it has y over r. Same reasoning, cosine is x over r, tan is y over x, and cotan is x over y. So in the unit circle where r is 1, sine theta is simply equal to the y value of the point. Cos theta is equal to the x value of the point. Remember we got those points when we put our special triangles on that circle and we looked at the lengths of the sides. So every point on the unit circle has coordinates x, y, which can be written as cosine comma sine. Tan is we take sine divided by cosine. This is on your formula sheet, and so is the formula for cotan. So example 1, use the unit circle to find the exact values of all the trigonometric ratios for a rotational angle of sine 300. Give each answer with a rational denominator. So you can do this using your unit circle, you can do this using your special triangles, you can do this using the hand trick, which I'll post a separate video for. All of them are going to give you the same answer. So sine 300. So first of all, we're working with the angle 300. We know that that's in quadrant 4. So right away, we should know which ones are going to be positive and which ones are going to be negative. We have that cosine is positive here. So cosine will be positive, which also means its reciprocal will be positive. That also tells us the rest will be negative. So if you're using your unit circle, you see that you have an arm there that's 300 degrees, has an x coordinate of 1/2 and a y coordinate of negative root 3 over 2. So the x coordinate tells you the cosine, which then we can make the secant. The y value tells you the sine. And we can take the reciprocal. Now it asks for a rational denominator, so we'll multiply top and bottom by root 3 here to give us 2 root 3 over 3. Tan, well now we need to divide the 2. And when we divide the 2, we get negative root 3. Cotan gives us negative 1 over root 3, timesing both by root 3. Now, if you don't have the whole unit circle memorized, how are you going to do this using your triangles or your hand tricks? Then you'd have to find the reference angle, which is 60 degrees. So if you're doing the hand trick, you'd close your index finger, which is your 60 degrees. Cosine, you have one finger above that, so that's 1 over 2, or root 1 over 2. Sine, you have 3 fingers beneath the closed finger, which is root 3 over 2. And then all we have to change is whether they're positive or negative, and you should know that using the cast rule. Example 2, use the unit circle to find the exact value of. So now we're just working in radians. Cos is 3 pi over 4. So again, if you have your unit circle out and you have it memorized, which for me it's a bit to memorize, but you can see that an angle of 3 pi over 4 goes with the coordinate point negative root 2 over 2, comma root 2 over 2. So this tells us the cosine is negative root 2 over 2. If you're doing this with the hand trick with the special triangles, you're going to work with the reference angle, which will be root 4. So you can close your middle finger if you're using the hand trick, and cosine are the fingers above. Well, there's 2, so that means root 2 over 2. 3 pi over 4 is in quadrant 2. Cosine's negative in quadrant 2, so it's negative. Cotan of 5 pi over 3. Well, cotan is cos over sine, so we're going to take the x-coordinate of the point. That goes with 5 over 3. So 5 pi over 3 has an x-coordinate of 1/2 and a y-coordinate of negative root 3 over 2. So this does give us negative 1 over root 3 or negative root 3 over 3. So again, if you're using the hand trick, you'd use a reference angle of pi over 3, which is your pointer finger. Your x-coordinate is root 1 over 2. Your y-coordinate is root 3 over 2. You still need to do the division for the even circle the hand trick, special practice. Okay, tan of 600. Well, if we subtract 360, we do find out that this is actually equal to the tan of 240, which puts us in quadrant 3, where tan is going to be positive. So here we're going to take our y-coordinate divided by our x-coordinate. So we take root 3 over 2 divided by negative 1/2, which gives us root 3. Last one, cosecant of 3 pi. Well, it's easiest if we work with the principal angle between 0 and 2 pi. So subtracting 2 pi from this tells us this would be coterminal with the angle pi. The angle pi is along the negative x-axis. It has an x-coordinate of negative 1 and a y-coordinate of 0. Remember, cosecant is the reciprocal of sine. So sine of pi is 0, so cosecant is 1 over 0, which is undefined. Okay, 3, use a calculator to determine to 4 decimal places the coordinates of the point on the unit circle that correspond to the rotation of 2/5 pi. Well, this means we need to calculate the cos of 2 pi over 5 and the sine of 2 pi over 5. This is an angle in radians, so you'd have to make sure your calculator is in radian mode. And you get the coordinate 0.3090 and 0.9511. Example 4. We have point P is root 2 over 2, negative root 2 over 2, and Q is negative 1/2 root 3 over 2, are 2 points on the unit circle. If an object rotates counterclockwise from P to Q, through what angle has it rotated? Answer in degrees and in radians. So it helps to draw a picture, so at least we know which quadrant we're in. So a positive x value and a negative y value. P is over here. Q is negative x, positive y up here. So when it asks for what angle did we rotate through, we are looking for this angle. So the simplest way of doing this is you can find the reference angle for P and for Q, and then that allows us to add up these angles to see what our angles between the two. So if I'm looking at point P, again, if you have the unit circle in front of you, if you have it memorized, it's quite easy to just find the rotational angle. Maybe that's not the case, so we do need to find the reference angle here. Root 2 over 2, root 2 over 2. The only way we get, if we're using the hand trick, 2 fingers on top, 2 fingers on the bottom, is if we close our middle finger, which means that this has a reference angle of pi over 4. 45 degrees. Q is a little bit trickier. So if we have an x value of negative 1/2 and a y value of root 3 over 2. Well, in order to have one finger on top, that means we're closing our pointer finger, which is our 60-degree reference angle, or pi over 3. How is that going to help us figure out this whole angle? Well, if I take this first piece here, I'm going to work in degrees first. It's a little bit easier. 45 degrees. From the positive x-axis to the positive y-axis is a 90-degree piece. From the y-axis to this line represented by Q. Well, if the reference angle is 60, that tells me this angle is 30. So now we add them up. 45 plus 90 plus 30 gives us 160 degrees. If we're working in radians, we're going to have pi over 4 plus pi over 2 plus pi over 6. This is pi over 6. And this is going to give us 11 pi over 12 radians. 5, without using a calculator, 2 is cos of 7 pi over 4. We love putting questions like this on our diploma exam, where they kind of combine 2 units. So the log base 2 of cos of 7 pi over 4. 7 pi over 4 has a reference angle of pi over 4, which means anything with a reference angle of pi over 4 has a cosine ratio of root 2 over 2. We need to figure out which quadrant this is in to decide whether it's positive or negative. Remember, we're starting here. 180 degrees would be 4 pi over 4. All the way back here is 2 pi, which is the same as 8 pi over 4. So 7 pi over 4 is in quadrant 4. Cosine is positive in quadrant 4. So this is positive root 2 over 2. So now to find the value of this, well, we can rewrite this with powers. This is 2 to the 1/2 over 2 to the 1. This is the same as log base 2 of 2 to the negative 1/2 when we subtract the powers. We can bring that power up front using the logarithm laws. And we have negative 1/2 times log base 2 of 2. Log base 2 of 2 is 1, so our answer is negative 1/2. Example 6. The point A, negative 0.6157, comma negative 0.7880 lies on the unit circle. Determine the value of theta, where theta is the angle made by the positive x-axis and the line passing through A. So I have a point A somewhere here that has a negative x value and a negative y value. So we start by finding our reference angle. We know that the sine of the angle is negative 0.7880. The cosine of the angle is negative 0.6157. So we need to find the reference angle. We can use either one of these ratios by finding the inverse of them. So I can say inverse sine of negative 0.7880. Sorry, I'm going to use the positive version, of course, when I put it in. This gives me a reference angle of 52 degrees. And it's asking the value of theta, where theta is the angle made by the positive x-axis and the line passing through A. So this is the angle I'm looking for. It'll be 180 plus the reference angle. And I could convert this to radians if you wanted to, but it doesn't really specify here, so we'll just keep it in degrees. Okay, this talks about the alternative method using the unit circle is using the reference triangles, which are our special triangles. So you can definitely use these. You can memorize the unit circle. You can use the hand trick. Anything works. Okay, so the next part of the unit circle is actually talking about the circle itself. So point xy can be any point on the unit circle as shown in the diagram. Use the Pythagorean theorem to determine the equation of the unit circle. Well, we know the radius is 1. We know this is a right-handed triangle. So therefore, we have that the equation of the unit circle is x squared plus y squared equals 1 squared. but 1 squared is 1, so this is x squared plus y squared equals 1. And in fact, this does expand out to any any circle. It would be x squared plus y squared plus the radius squared. Oh, sorry, equals the radius squared. So this is the equation that works for any circle. This doesn't come up very often, but it's pretty obvious, so it's worth mentioning. So determine which of the following points lie on the unit circle. So if we have a question like this, all we need to check is if the x-coordinate plus the y-coordinate equals 1. And in this case, you have 1 plus 1/4. This equals 1/2, which does not equal 1. So this one does not. Trying with the next one, let's see if you have 16 over 65 squared plus negative 63 over 65 squared. Does this equal 1? And in this case it does. So this is a point on the unit circle. So it's not one that we put on the angles that we have on there, but it still is somewhere on the unit circle. Next one, negative 2/3, comma, 5 over 3. Same thing, if negative 2/3 squared, 5 over 3 squared, it does equal 1. So this one is on there as well. The point negative 1/5 y lies on the unit circle in quadrant 3. Determine the value of y. So now we know it is on the unit circle. So to determine y, I'm still going to use the same equation. So I have negative 1/5 squared plus y squared equals 1. This gives me y squared equals 1 minus 1/25. So y squared equals 24 over 25. So then when we square root and simplify, we do get that y equals negative 2 root 6 over 5. The point determine the exact values of secant theta and cotan theta. Well, we know if this is on the unit circle, then that x-coordinate is our cosine ratio. Okay, well, if we know our cosine ratio, our secant ratio is just the reciprocal of that, which is -5. To find our cotan, we're going to take cos divided by sine. So the cotan, well, our cos is negative 1/5 divided by sine, which is negative root 6 over 5. Doing this division gives us 1 over 2 root 6. We want to rationalize denominators, which gives us root 6. See, determine the value of the angle to the nearest tenth of a radian. So as soon as it tells us our calculator, we could use the cosine or sine inverse here. Cos inverse of 1/5, and make sure you're in radians. You have to find your answer in radians. Is 1.94. Keeps going. Remember, this is our reference angle, so we need to figure out which quadrant we're in. We have a negative x value and a positive y value. We have negative x and negative y, because it told us here we were in quadrant 3. That's what allowed us to make sure that y value was negative here. So we are in quadrant 3. So what is that angle in quadrant 3? Well, if this is 1.3694 radians, we know to here is pi radians. So pi plus 1.3694 gives us to the nearest tenth 4.5 radians. So when we're asked to do a question like this, we do need some additional piece of information to tell us which quadrant is in. Otherwise, we don't know whether we should take the positive square root here or the negative square root. Okay, last example. Determine the equation of the circle with center at the origin and radius 8 units. Well, if we have a radius of 8, that means x squared plus y squared must equal 8 squared. If the point negative 4 b root 3 lies on the circle, determine all possible values of b. So negative 4 squared plus b root 3 squared must equal 64. So b root 3 squared is b squared times root 9, or b squared times 3. Equals 16. Subtracting 16 from both sides, we have 3b squared equals 48. Dividing by 3, we have b squared equals 16. Square rooting. Now all possible values are plus minus 4. So there is a point on the circle that has an x coordinate of negative 4 and a y value of 4 root 3. There's also a point on the circle that has an x coordinate of negative 4 and a y value of negative 4 root 3.